Okay, so what we're going to be working on today is multiplying binomials. Remember that from previous in class we have learned that binomials refers to a expression that has two different terms, meaning an x and a number, an x and a y, x squared. 3 would be a trinomial, and then any type of polynomial refers to the number that it has, so a 4-nomial, 5-nomial, 6-nomial. For the purposes of today, we're going to be multiplying only binomials. And that's just because mainly in Algebra 1 we focus on binomials. We will kind of touch on how you would modify what we're doing for other things, but for today we're just going to be working on binomial multiplication, and then also as we go beyond that, how you take that and you go ahead and add things to it. So sort of for today, what I want you to focus on as an essential question to make sure you understand today's lecture is how can we use a generic rectangle to multiply binomials. Now, a generic rectangle can be called a lot of different things. If you're in biology, it's often called a Punnett square. So if you're familiar with the Punnett square from either biology or possibly maybe 7th grade math, then you'll remember how a Punnett square is used, and that's basically what we're doing today. Okay, so remember when you find the area of a rectangle, such as this one, we do so by multiplying each of the sides. Remember as well that when you have a rectangle, we would have a 10 here and a 3 there. So don't think that it's, when I say each of the sides, you don't go 3 times 10 times 3 times 10. You just multiply simply those two sides that are there. Okay, so what we would do in this case is we'd multiply those two sides, 3 times 10, which would give me 30. And it's important to remember that because what we're going to be doing today is just simply multiplying those two sides. The same is true as if you have variables. So in this case, it's basically 2x times 7. If you remember from earlier, that just means I'm going to multiply 2 times 7 and leave x in there. So it'd be 14x. Basically, these two types of multiplication are pretty much mostly what we're going to be doing. The only other one we're going to use is when you have x on both of them. In this case, you would go ahead and multiply 5 times 6, which is 30, but x times x is equal to x squared. So those sort of three operations you see right there will be what we use for our what we call generic rectangle or a Punnett square in science. Okay, so we're going to basically use this thing right here, which we call a generic rectangle. Basically, it's called a generic rectangle because it's not to scale. So that means, you know, if a 5 is next to a 10, the 10 doesn't have to be twice as big. We use it as a tool, so we're not caring about scale or things being drawn exactly correctly for size. We only want to use it as a tool for us. So sometimes they'll be the same number, sometimes they'll be vastly different numbers. A 20 and a 1 doesn't have to be really big different sizes. So this is a weapon or a tool for us to be able to do these problems. Okay, so we're going to start off right off the bat with an example. Okay, we're going to start off with our generic rectangle, and what we're going to do is we're going to set it up. Okay, now the first thing I do is I go ahead and write my 4x there and my negative 3 right there. Very important that you don't write something like 4x minus 3. A lot of times what people do, they write something along the lines of 2x plus 5. And then what they do down here is they write 4x minus 3, or sometimes they put the minus like that. The problem with doing that is you sometimes forget that that's really not a minus 3, it's really a negative 3. And so it's very important to look at it in that way. And then over here I've got my 2x and my positive 5. Notice the space in between them. That is important. That is to make sure you notice that's a positive 5. That's a negative 3. When you say it out loud, I don't want you to say 2x plus 5, 2x and plus 5. I want you to say 2x and positive 5, 4x and negative 3. A lot of times people say 2x goes there and 5 goes in the other spot. It's not 5, it's positive 5. Of course, 5 and positive 5 are the same, but it's about remembering that a minus sign means we have a negative in the problem. Now, all we're going to do is we're going to apply that multiplication. So for your purposes, to make it simple for you to see, if this is the first time you've seen it, we're going to kind of bring each rectangle off to the side for you. So first, I'm going to take a look at that one that's highlighted in blue right now. Okay, the sides of it are made up of 4x and 2x. Okay, so now I'm going to follow my rules. If you remember, 2 times 4 is going to be 8, and x times x gives me x squared. So x squared goes in there, and I'm going to now move on to the next one. Obviously, when you're doing these problems, you don't necessarily have to like write every single square again, but it helps you to maybe visualize it when you get to learn the process. Once you get it down, you'll just be zipping along and doing these quickly. All right, so now I want to identify what are the sides of this. And this gets a little trickier when it's off to the side like this. What you want to remember here is that very obviously that top one's going to be 5. But the question is, what is this side right there? That's the one that people get a little confused about. What you need to realize is that 4 would be right there on that side. It's the same side. So then this over here must also be 4x. And that helps people a lot to get that visual down. Okay, so my two sides are 5 and 4x. Multiplying that out, you just get 4 times 5, which is 20 with the x. Some people will quickly notice, hey, I have an x in the upper right-hand one, an x squared in the upper left-hand one, and that is always true. You'll also have in the bottom left an x, and in the bottom right just a whole number. Noticing those sort of patterns in math help to make things a lot easier because you don't have to remember the rules quite as much as just things that can help you make connections in your brain. All right, so moving down to the bottom left-hand corner, the sides of that are going to be 2x from up above and -3 from on the side. Just like before, one of those sides, the -3, is very obvious. The 2x, you may want to kind of take your finger and move it straight down so you can visualize where it is if you have difficulty with that. Multiplying this out, I'm going to get -6x, and that goes in that spot right there. The last square is the one that, if you are not familiar with this process, might be the most confusing because none of the sides are labeled. So remember that what you have here is you have that -3 off to the side, and that's that side of the rectangle, and then this +5 is the top of the rectangle. So multiplying those out, you're going to get very simply 3 times 5, which is, of course, 15. However, you have to be a little careful. That's a -3. Common mistake is people forget the negative sign. That is why when we wrote it out, we put that negative sign there. -3 times 5 is -15, and that goes in the last spot. Okay. However, we're not quite done. The reason is we need to pay attention to the different parts and combine any like terms that we can. This right here is the whole of our answer. So if we sort of write that out long ways, you'll see those are the 4 things that we have. We have an 8x squared, a 20x, a -6x, and a -15. Combining like terms, all we have to do is take that 20 and that -6 and combine them. Okay, in this case, that's 20 minus 6, which is 14x. Okay, at that point, we are done. Why? Because x squared is different than x. If you remember the rules from combining like terms, those things are very different. They cannot be mixed like monkeys and snakes. You can't put them together and make a monkey snake. So we have to leave them separate, and we're done with the problem. Okay, here's one more example to try before I have you start doing some on your own. When we do the examples on your own, even though you may have other ways to do it, you may have learned in a previous algebra class how to do something else called FOIL. I want you to focus on using the Punnett square because we do need to know that method. Even if FOIL is a good method for you, you also need to know how to use the Punnett square in my class. So what we're going to do is we're going to go ahead and apply the sides. One question that a lot of students ask is, uh-oh, I put the 5x on top and the 7 on the other side. That's totally fine. You can do that as long as things are lined up, meaning you cannot put, for example here, I can't make my square and like do it like this. Okay, 5x and x and 7 and +3 up here. Because now I've broken up my binomials. Those are not my binomials I started with. I didn't start with x plus 7 and 5x plus 3. So it doesn't matter if I put the whole binomial on the side or on the top, but it is important that I make sure that they stay together. So the 5x and the 7 need to stay together, and the x and 3 as well. So now all I'm going to do is I'm going to simply multiply my sides. 5x and x makes 5x squared. 5x times 3 is 15x, because 3 times 5 is 15. Remember on this one that there is sort of an invisible 1 in front of here, especially if you get confused on that. So I've got 1x times 7, which is 7 times 1, 7x. And the bottom right-hand corner is going to be 3 times 7, which is 21. So as you can see, very quick to do this once you get good at it. You can write the rectangles off to the side if you need to, or you can even write like little numbers on there like this. You could write a little 3 and a little 7 if that helps you out, to help you remember what's being multiplied. Don't need to, but you can if that helps you. Whatever's going to make it possible for you to do this. I always do this. Do not skip the step where you write it out. Okay, I know that that's going to be like, ugh, groan. Okay, but the thing is, very often people forget negative signs. They make mathematical errors. So I want to see that step written out. If I'm grading it, I can see that you did it. I can see where your work came from. It's actually a lot easier for me to look there first and see a mistake and then go up and figure out where that mistake came from. Whether you wrote it wrong or you, instead of x plus 3, wrote x plus 2, it's important to write that step out, and then also you can kind of organize your thoughts a little bit. Make sure you got it all labeled correctly, make sure you didn't forget a minus sign, and make sure your answer makes sense in the end. Then, of course, combine like terms. 15 and 7 get combined. The other two do not because they're not like terms, and you get 5x squared plus 22x plus 21. Okay, now I know it says try as a group here, but what I want you to do is I want you to go ahead and try this one on your own. You're going to do quite a few of these, and they do go pretty quickly. So draw yourself a Punnett square, pause the program, do the math, write out that middle step where you write out all the pieces inside the Punnett square, and simplify the final term. After you do that, we'll go over it real quickly to check and see if you're getting it correct. And if you want to go back to previous stuff, if you're not, you can pause it, rewind, go back, and then come back later. So go ahead and pause it, and we'll go over the answer in a second. Okay, so hopefully you drew your Punnett square, labeled your sides. Remember, it doesn't matter how you labeled the sides as long as the binomials stay together. Please make sure on your paper you put that -5 off by itself. You didn't just have a minus sign hanging out in the middle. It's very important that you do that. Again, you may think, what's the difference? I've seen a ton of students do this, and I know the mistakes students make. This will help prevent some of those mistakes for you. Okay, multiplying it out, 4x squared, -5x, positive 4x, and -5. You should have written that out, including all the pieces. I like to start with the x squared, end with the -5, so the two things in the middle are the ones that combine. That's not absolutely necessary, but it's a good idea to do that just to keep the common like terms together. And when you combine those, you get -1x. Okay, it's also possible you could have left off the 1, just had a -x. In fact, often in books and stuff, they wouldn't have that 1 there. Okay, same thing as before. Go ahead and pause the program. Try this one on your own. Make sure you use the Punnett square. Make sure you write your middle step. Okay, so go ahead and label both sides of your Punnett square. I chose to use x minus 9 on the left side, x minus 7 on the top. You probably have noticed by now I do the same thing every single time. That's just a force of habit, but I do believe in math that the most repetition you can do, the better that helps your committing it to your memory. I don't know if there's data that proves that, but I really feel like that's a way to help you make sure you're doing it every single time. I always tell my students, try to do it the same way as much as possible, because you want to build a routine to help you remember it from 2 years from now, not when you leave this class or not when you finish this video and you feel like, oh man, I got this. It's a week later, a month later, a year later, 2 years later, when you're in Algebra 2 and you need this tool. I want you to be able to pull back to this. Maybe not remember it perfect, but come back to you quickly. So try to have a pattern and repetition. There isn't a right or wrong way, but try to follow the same way every time if you can. Okay, so now I'm going to multiply it out. Okay, obviously I'm going to get -7x, -9x, and positive 63. Writing out my middle steps and combining like terms. If you find yourself making like multiplication errors or negative errors, things like that, combine like term errors, and your mistakes are not in the doing the problem, it's in the computation, the adding, subtracting, multiplying, dividing, especially of negatives, then you may want to take some extra time when you have a moment and kind of go back and review that stuff. On that quiz website, there's a lot of good resources on there for just straight up addition, subtraction, multiplication, division practice. You don't need a test code from me. Just go in there, click on, I think it's under integers, and just do some basic arithmetic. It won't hurt. It's always good practice. Okay, moving along to the next one. Go ahead, pause it. When you're done, hit play. We'll check your answer. Okay, so again, you'll notice I always label the left side with the first one, and the second one goes on the top. Multiplying it out, You notice this time I got quite a large number for my x squared. It doesn't matter. There is no right or wrong. Usually when you see them in classes, you do tend to see smaller numbers up there. And that has to do with when we do factoring. You'll see it just becomes larger numbers to deal with. But when we're doing multiplying binomials, pretty much anything is fair game. So now we're going to go ahead and write it out and then combine like terms. 28 minus 5 is 23. You've probably noticed the only thing I ever combine is those two middle ones. That's why this is a pretty easy process once you get it. Okay, this one may be a little bit different, but it's going to be the exact same process. What I want you to pay attention to as you do it on your own is what's different about this one than the other examples in terms of our final answer, and how might what we started with explain that a little bit. See if you can think about it when you get your answer. Okay, so pause it, hit play when you're done. Okay, so we're going to go ahead and label it. Multiply it out. I get 9x squared, positive 12x, negative 12x, and negative 16. So right off the bat, you may notice that I have a positive 12 and a negative 12. When I go ahead and I subtract those, they cancel out. Okay, 12 minus 12 is 0. I don't put 0x in there because I can put 0x, 0x cubed, 0x to the fourth, 0y, 0z, 0q, 0 beta, 0 alpha. I could go on forever. There's 0 of a lot of things. We don't list them. So what we do list is what we have, 9x squared minus 16. So looking back at our original problem, I want to know, did you see anything about that original problem that might have been clues? Obviously, you can't answer me through a video, so it's something to think about. All right, now this one I want you to try on your own, but I want you to think a little bit. This is a little different. Now we've introduced the letter Y into there. It doesn't change anything. Just try to follow the process. I'm a big proponent of try it, and then when you do something weird and you get it right, it feels kind of cool. So give it a try. Follow what you think might be right. I will give you one hint. There's no difference between xy and yx. They're the same thing, so don't worry about that. But go ahead and give it a try. See what you come up with, and then we'll go over the answer together. All right. So here we go. I'm going to go ahead and label my sides here. In this case, 3x and 5x make 15x squared. So far, nothing different. Now, this might be the first place where you get a little bit goofed up. People freeze, basically, when they do stuff like this. Just remember, when you had 2 times 3x, you didn't freeze. You just did 2 times 3 and put an x on there. Same thing is true here. I've got a 2 and a 3. That's going to make 6. And I've got an x and a y, so I put the x and the y there. If you remember, that 6x means 6 times x. So what I have here is 6 times x times y. That's what I needed. The only things I knew how to multiply were a 2 and a 3. Okay, now moving down to the bottom left, 5 and negative 5 make negative 25. And I've got an x and a y. This goes back to what I said before. There's no difference between yx and xy. Typically, you write the x before the y. I don't know if it's because it's the first letter, but that's sort of the way they usually do it in math books. You'll see the x usually before the y, unless the power is higher. And we'll talk about that again also later in class. Not today. And the last one may be the second place where you messed up. One of the things I see a lot of students here is I get negative 10y. They don't answer on the upper left-hand one, 15x. They remember x times x is x squared, but again, you've practiced this more. If you have two y's, y times y, that needs to be y squared. So I'm going to end up with negative 10y squared. And then they get to this part and they go, oh my gosh, I don't know what to do with all this. Do I put the x squareds and the y squareds together? No, they're different. Okay? The only thing you have that is the same, if you really look at it, that means that has the same exponent, the same base with an exponent. The only ones that are the same are this and this. They both have xy as their base. So it means I can combine them. Negative 25 and 6 make negative 19. So even though it looks really crazy, the process is the same. And definitely expect that I'm going to put these types of problems in there, because if I give you only super simple ones and you get something like this in a scenario where you need it, it's not going to help you. Okay, so try one more. Again with x and y. Notice again up there that we have some sort of a weird pattern going on, and you may see that when you do your final problem. So pause it, give it a try. Okay, so here we go. Labeling my Punnett square. Can probably already see I'm going to get some pretty big numbers here. 8 times 8 is not 16. Very common mistake. 8 times 8 is 64. Be careful. A lot of times people will add these things. Think about rectangles. You always multiply. Okay, just following our rule from before, that'd be a 24xy. And then here, negative 3 times 8 is negative 24xy. So you might see that we had that same pattern from before where one's positive and one's negative. Now at the end, 3 times 3 is 9. Negative 3 makes it a negative 9y squared. Writing it out, you'll notice, hey, 24xy and negative 24xy, they're going to cancel out and make 0. We don't write it, and we end up with 64x squared minus 9y squared. Again, look at those numbers, 64, 9, nothing in the middle, squareds. Look back at our original problem. See if you can find any patterns there. It'd be very helpful to you in some ways to make some really cool shortcuts and make the job a lot easier for you later on, or even now for that matter. Okay, so what we're going to do now is we're going to take that and we're going to apply it one step further. We're going to look at this and we're going to apply it basically like an order of operations problem. When I've done these problems in the past with my students, a lot of times they don't see them until the STAR test or some sort of standard test. And so they freak out. They go, I don't know how to do this. Well, you do. It's basically what we just learned, which is how to multiply two binomials, as you see right there. But then there's also this sort of extra stuff off to the side over here. This stuff to the right side that, is basically looks like stuff we've used before, but is not what we're used to. Well, what you need to remember is this here is all addition or could be subtraction. In this case, it's all addition. On the left side, what we have is what we're used to, okay, what we've been doing. But think about it. What was the operation we did every single time we did these problems? Every side of the square was multiplied. This is multiplication. If we go back to PEMDAS, okay, basics or order of operations, for your teachers that didn't use that, multiplication always comes before addition or subtraction. So all we're going to do is we're going to treat it like an order of operations problem. We're going to do the multiplication part first, and then we're going to worry about the addition part later. Okay, well, how do we multiply? We use the Punnett square. We just learned how to do that. We label all the sides. Okay, however, look what I did there. I brought that stuff from right here straight down. Now, if you took order of operations from me in pre-algebra, you know this. If you had anybody else, it's always a good idea before you solve the other part to go ahead and write that extra stuff down below because you don't forget it then. Some people will forget the whole part. They get to the end, they've done all this work, it's just there. Okay, it's gone. They forgot all about it. Definitely going to get the wrong answer. So what we want to do is we want to go ahead and bring that down. Then we're going to label our sides like we're used to. Okay, and follow the process. 2 times 4 is 8x squared. 2 times 5 is 10x. 1 times 4 is 4x. And 1 times 5 is, of course, 5. So now I'm going to do exactly what I'm used to doing. Okay, I'm going to bring all that stuff down. I've got 10x and 4x, which give me my 14x, plus 5. Notice that I left that in green like we'd been doing, but on the right side, I wrote down my plus 3x plus 1. Now I simply combine like terms. You could also do this a little bit differently. You could start off by sort of like writing 8x squared plus 10x plus 4x plus 3x plus 5 plus 1 and sort of rearrange it so that all the x's are next to each other. But I feel that this gives a better visual of what's really going on. We got 8x squared plus 14x plus 5 on the left side. That's what the Punnett square, the generic rectangle, did for us. We still have a 3x and 1 left over. Now we combine like terms. Okay, well, in this case, I combine this, and I can combine my 5 and my 1. Okay, so that's going to give me 8x squared plus 17x plus 6. So what I want you to do now is we're going to go ahead and try this. So, if that didn't really make sense to you, maybe rewind it, look at it again. But we're going to give you a chance to try a couple of them. All right, so I want you to try this one on your own. Remember to start off with the Punnett square and then do the addition and subtraction parts. Pause the program, hit play when you're ready. Okay. So notice I use my Punnett square, and I'm going to go ahead and bring down and label the sides. Okay, what you'll notice right off the bat is I have a 6x and a negative 6x. Those are going to cancel out. So all I'm left with is 12x squared minus 3, and then my minus 5x and positive 7 that come down from above. When I combine that all up, I'm going to get the negative 5x, the negative 3, and positive 7 come together to make a positive 4, 7 minus 3, and the 12x squared has nothing to combine. Okay, so go ahead and pause it. Give this one a try as well. You'll notice this time I put different stuff off to the right side. Shouldn't be any different. We're just combining different things at the end. So pause it. when you feel ready, go ahead and hit play. Okay, so we're going to go ahead and start off here. I make my Punnett square, my generic rectangle. I bring down the stuff from above, label my sides, and begin my multiplication process. 18x squared minus 9x plus 30x and minus 15. Okay, from there, I now combine like terms. 30 minus 9 gives me my 21. And now I be very careful here and I pay attention to what I'm combining. 18 minus 8 is 10x squared. 21x minus 2x is 19x, and the negative 15 has nothing to combine with. Okay, so at this point what I want you guys to do is I do have a practice quiz for you below. So go ahead and take a moment to try that out. Feel free to go through the video again if you need to, watch any parts a second time, even as you're doing the homework assignment. So go ahead and do that quiz, check it out, it'll give me feedback for tomorrow, and then please fill out the form below so I can get feedback on the video and how it made sense for you.